No, don't be silly.
Me?
Don't do something.
Yeah, exactly.
Stephen.
What?
Oh, what is my name? Name.
Go on.
No.
Fanula.
Fanula. White.
Fanula.
I'm white.
You're white. You're a white
Fair.
girl. Yes.
Oh, that's very Irish name.
No, she asked if there's an Irish name for Fuan, and I said no.
What about me?
So we have to pick a name that seems like Fuan. So
Yeah.
Lorraine said to her, Fiona.
No, I
You
know
found
that.
Fiona, but Fiona is short for Fanula
Yeah.
sometimes.
Really?
Well, no, not always, just sometimes. So Fanula is an Irish name that means fair. In other words, white girl.
Yeah.
You know. Yeah.
White.
Did you say Irish?
My heart is white.
Yes, indeed. Yes.
Did you say Irish?
No, not really. Dennis and Emer will be the best at it, I think.
But I thought you were Irish.
I know some. Once you leave school, you know, I have no ability to speak it because there's no opportunity to speak it because nobody speaks it. So, kind of like as soon as you leave school, then you start forgetting everything, you know. So,
At least you remember the name.
nearly, you know, yeah, like 15, 16 years ago was the last time I had to have a conversation in Irish for the speaking test. Because there's a speaking test in high school.
16 years ago?
Yeah.
Which means how you are?
32. Yeah. Soon I will be. But anyways, there's no opportunity, you know, like, this is why most people don't really speak it so well.
You can speak it first.
Huh?
You can speak it first.
Yeah, what words do you know though? Like seriously, do you know any Irish words?
Lana.
Stop.
The bus stop.
Ah,
Reverse hypothesis.
L-A-N-A.
Yeah.
It's time for
bus
sound.
lana.
Lana.
Yes.
Yeah, no.
That's not bus stop.
That's
Richmond Street. Right.
Stop,
Richmond.
Richmond.
Stroy the street, correct, yes.
Lana is like the name, right?
Lane, yeah.
There are some people who are actually called Lana, like girls.
That's an American name, Lana, yeah. It's slightly different. And not much though, slightly different. Any other words you know? Stefan, yes, thank you. Anything else?
But if you go to a shopping place and you speak Irish,
Oh,
would that be normal?
Street.
No,
Right.
not in Dublin.
Nothing.
You're learning Irish through Dublin bus. Well, you know what street is now. Yeah.
Riverside Cottage. It's time for sound.
Very good. Did you hear this every morning?
Yeah.
Every
Every day.
Every day. Yeah. Where are you coming from?
Me?
Yeah.
Very bothered.
Ballyboden. I'm trying to think of what other places you pass. Temple.
Real East. Oh, I forgot.
Which one's Terranure East? Terranure?
No.
Yes. What else would be good for you to know in Dublin? You know street.
What's I love you in Irish?
Gra is love.
Gra.
So that's in German. Ishli Badish.
Japan.
Yeah.
That's very rough for a word like love.
Huh?
That's very rough to say for a word like love.
Gra.
Yeah,
It's cheated.
whatever is the German version of
Liebe. Isn't
You
it?
speak him?
No.
But you know,
I know some words, yeah, but what a Guten Tag. What else do I know? Guten Nacht. Good day and good night.
You can actually have a good morning.
Good morning, yes.
Good
Yes.
morning.
Guten Morgen, yes.
Ich bin
Stephen.
yeah.
Ich bin math teacher.
Come on, Papa.
No,
That's French, yes. Yeah. Yeah. Okay. Is this it now? Just the 5? Because
No.
Andrew's at GNIB.
GNIB.
Yahoo's at GNIB.
Only Andrew.
And
Faisal.
By that on the street.
He went to Cork. Oh yeah.
Because he didn't want to
He didn't want to go to classes. Yeah, no, I believe that. And who else? And Nadir. And Omar.
Yeah.
All right. Okay, can you write this down? Next lesson. What you have for lunch?
No.
Chicken burger?
No, not chicken. Lamb.
Lamb what?
Lamb burger.
Lamb burger. Where?
In the canteen today.
Nice.
Yeah.
Chips?
Yeah, cheap.
Coke?
No, not have Coke.
Orange?
No.
Well, what do you drink?
chocolate milk.
Chocolate milk?
No. Just water.
Just water?
I'm too fat. The hamburger today is so big.
Yes.
Wow. And I eat
How much?
all 5 euro.
With chips?
Yeah, all of them.
Good deal.
Yeah.
Good deal. And it was good? Tasty?
Yeah, that's too much.
Too much? Did you eat it all?
I eat all.
But you just said it was too much.
I try to eat all. I don't want to waste any.
Maybe you could share with someone.
Who?
Just no friend.
And also at that time I sit with my friend and they also gave me more chips.
So you had burger,
And
chips,
that's
and more chips. So your diet is going well. Yeah. I think maybe you should walk home today.
But I'm in Ballycullen.
But you had extra chips. Alright, capacitance and capacitors. Does anybody know these words?
Yes.
You,
Yeah.
you do?
They were removed from the syllabus, I was thinking.
Oh, I see, okay.
That's why I wrote it.
It's called the energy.
Yeah. So the first definition, the following picture here. Well, maybe not that one because that's a bit ugly. I'll draw my own one. So you have 2 plates, and you have a switch here and some power. And these plates are close together. I know they don't look like it in the picture. And they don't touch. And they're made of something like copper. So you close the switch. Or actually, let me put a little light bulb here. So you close the switch and the light turns on, of course. And then you open the switch and the light...
No, not on.
It's on for a short time because what happened is some charge built up on the plates. So when the switch closes, this charge here is then released. So the light continues on for a short time.
That's why it's called a capacitor.
Yeah. So this is a capacitor. A capacitor holds a small charge for a short time and releases it.
But what's the point of it?
Yeah, usually they're used for when you want a sudden release of energy. So they build up like an I don't know,
Camera?
like a camera, yeah,
Or like charge something for a while and then leave it.
and then release the energy at once, a burst of energy. Yeah, you get the idea? They have other uses too. So this is a capacitor. So a capacitor, also called a condenser, but nobody calls it that anymore. A capacitor is an electronic device that stores electric energy. You got that? Yeah. Continue. Okay. So how do we measure how big a capacitor is? We have a unit called capacitance. It measures how good the capacitor is, how much energy it can store, like its size. Yeah, it measures the size of the capacitor. So capacitance is the ability to store charge. A common device to do this is a capacitor, obviously, and the unit for capacitance is the farad.
Not Farad.
Farad. Sorry, I said had. The moment I said that, I realized I said a person's name. Yeah, farad. Yeah. Mathematically, we define capacitance as the charge that can be held over the voltage between the plates. So, if the C is big, then it means the Q is big. You can hold a lot of charge.
What is the voltage small?
Yeah, the voltage there, how can I explain this? Capacitance is the charge that can be held per volt. So we don't really care about the voltage because we can change that because it's just a cell. So it's this charge per volt. So 1 farad is 1 coulomb per 1 volt. That is coulomb per volt. Okay. They frequently ask this definition in the exam. Can you write this down, Lee? Even if you are famous, you still need to write this down. No, because I was expecting an email from Connell looking for your predicted grades or whoever, and I never got that email, so nobody asked me for it yesterday. So you still have a chance to impress me.
Yeah, but can't you have it anyway? Do they have to ask?
How can I explain this? Have you had a job before? Of course not. So at some point in the future, when you enter the workforce, you will discover you'll have enough to be doing that you won't feel the need to do extra work that people don't ask you to do. You might not understand this right now, but in the future, trust me, in 10 years' time, someone will ask you, well, why don't you just do that thing they didn't ask you to do? And you'll be like,
Because they don't ask.
yes. So, it's a little tip for you, okay? Alright, did you write this down now? Not yet? Okay. I suspect Connell or Emer or someone will come looking for it soon though. So.
Well, at least like something for each of us.
Oh.
Nothing?
No, because I haven't thought about it. I'll think about it the moment someone asks me for it. Okay, you got this? Right, here's an example, as you were saying. The capacitor builds up a charge, and then all of a sudden the charge is released and makes the flash. Can we think of other examples? You need to think of something that needs to build up a charge and then release.
About 3 books about nothing you wouldn't release it directly on it.
No, we want a sudden release.
How about the music in the light
The what?
The light in the light source.
The light in the what?
Light source.
Live show. Yeah, that's kind of the same thing as this though. Something else. Something not light. You could have them in a car for the spark plug. The spark plug is the electricity that makes the engine start. Never mind.
The first push.
The first push, yeah. Yeah.
Religion,
Huh?
religion.
No. This one, in the hospital.
Oh.
A very big capacitor. Yeah? Okay. So, here is a question I want you to try using the new formula. A flash camera has a small capacitor in it. When you press the button, the capacitor charges up until flash. The value of capacitance is 1500 microfarads and is charged up using a voltage of 380 volts. How much charge is held in the capacitor? So what is the Q? I want you to calculate that, please.
Is that micro?
It is. Which is?
I don't know.
I know, but I want to see what she says. Yeah?
Minus 6.
Yes. What were you going to say? Yeah? Minus 6, yeah. Okay, try this one then.
Oh, 0.57.
0.57 watt. Coulombs. Coulombs. C for coulombs. Don't give me 0.57, give me millicoulombs. How many millicoulombs?
570.
570, yeah. What's so funny?
I use calculator.
That is funny. 570 millicoulombs. Is that okay? Yeah? Now, let's see. We'll look at some rules. So, first one is if the capacitors are parallel, the capacitance adds together. So, I'll draw this as well. So, we'll look at parallel first. Fuang, which one is parallel and which one's a series? Show me with your hands.
Huh?
Parallel
Parallel.
and series? Yes, correct. Don't look so worried.
It's like a length.
It's good. I'm trying to help your English. We all are trying to help your English, right? Yes, okay. Let's draw this one now. So when the capacitors are parallel, C1, C2, the total capacitance is C1 plus C2. Can you write this down? And then we'll do a short little proof if I remember how.
Is that a zero of capacitance?
Oh yeah, sorry, it is, yeah, because capacitors are actually usually just two copper plates. You got this? Now, let's say the voltage here, we'll call it is V. What's the voltage here? And what's the voltage here?
V1, V2.
Yeah, but they're all the same. Because remember, yeah, but when they're parallel,
Equal.
they're equal. Yeah? So here, what's the voltage? It must be the same V as this V. Okay? Because this V is for before the capacitors and after the capacitors, and this one is before the capacitor and after the capacitor. So the V must be the same. You remember you have Q, what's the formula? C equals Q over V. Yes? So the what am I saying? I've lost one. My goodness, I've lost what I was thinking. One moment, I need more coffee, please. No. Well, they happen more so after 3 o'clock on a Friday.
Yep.
Maybe you don't need the proof of this.
No, I don't understand.
Oh, you need the proof?
Yeah.
I'll remember this. Wow. I'll remember this. Okay, let's try again. Maybe I could look it up. Okay, so this one here has a charge, we'll call it Q1. This one here has a charge, we'll call it Q2. This one has a capacitance, we'll call it C1. And this one has capacitance of C2. And we're trying to find the formula here for what the capacitance is here for this one. Let's pretend we don't know it. Okay, so here we can say C1 equals Q1 over V1. And here we can say C2 equals, oh sorry, not V1 but V, because they're all the same. And C2 equals Q2 over V. Yeah? So, what happens here when the current, remember, current is just charge per time. What happens when charge or current comes together? What happens to the total? Is it the same or is it different? It's different. What would it be? If this is Q1 here and this is Q1 here, how much charge would be here if it moved? Imagine Q1 moves down here and Q2 moves to here, how much charge do you get? Q1 plus Q2. So in other words, the total charge here is Q1 plus Q2. Yeah? So you could say then here that C will be the total charge over the total voltage, which is V, which is Q1 over V plus Q2 over V, which is C1 plus C2.
Oh, that's after they are added together.
This is like the equivalent total capacitor when you try to combine them into one capacitor. So it's like adding them together into one capacitor. So that's the proof of the formula for this one here. Yeah? Yeah, it's okay? It's okay. Now, let's continue. So you could probably have a guess. Remember, voltage is the same. Charge is additive and different. Again, that's what we talked about last time. Series. We have this formula. What about the voltage when it's in series? Same or different? Voltage? No. Wakey up. Voltage in series, the same or different? Different but additive. And charge? Same. Let's prove this formula.
No.
Yes. You can't choose. Right, so this one here is C1, this one here is C2, this one here is Q1, this one here is Q2, and we're trying to replace it with just one capacitor of C and Q, and we want to know what it is. Yeah? So we know for the current, the charge, Q1 and Q2 are the same. So we have our first rule, Q1 equals Q2. Yeah? Okay, and here we can say, oh yeah, we need voltages. This one we'll have to call V1, and this one here will be V2. But what would this one be? V1 plus V2, very good. That's that one there. Here, I can say C1 equals Q1 over V1, and here C2 equals Q2 over V2. So you can say C1 V1 equals Q1, and C2V2 equals Q2. But these are equal, aren't they? So you get C1V1 equals Z2V2. Now if you look here, you can say C total equals Q total over V1 plus V2, V total. But this Q is also the same as these Q's. Yeah, so let's see, we want to get, so we can get C, V1 plus V2 equals Q. Yeah? Is that okay so far? Okay, so something happens next. Give me a moment. I need to put these three equations together.
What were we,
But now I want to.
what were we trying to prove? Which formula?
Please, leave me alone. 1 over C formula. So, here, I can say V1 equals Q1 over C1, V2 equals Q2 over C2. I can put them in here and I get C Q1 over C1 plus Q2 over C2 equals Q. But Q1 and Q2 and Q are, and then I could divide by C. Yeah, now you see, you didn't believe in me. I could feel it. But I got it in the end. Okay? So these are the proofs, which of course you don't need, but you know, some students like to see the proofs.
Not me.
Okay, so can you add these formulas to your notes? It's really the C's that are new formulas.
It's like the electric.
Yeah, that's what I'm saying. It's only the C,
Yeah.
the capacitance, that's new. Yeah. Yeah. Yeah, I understand. It seems like it should be the same when you put them together. And let me try to explain here. This is, we'll say, R1, and this here is R2, and this here is I1. No, I'm sorry. I will draw it like this. This one here is R1, and this here is I1, the ammeter. And then this one here is R2, and this one here is I2, like this. You know that the I1 will equal the I2. Yes? Now, you have this formula, do you remember? I equals Q over T. So that means Q1, so if these weren't resistors, if these were capacitors, you would have Q1 over T equals Q2 over T, so Q1 equals Q2. So there is other reasons as well. For example, here, this is negative, this is positive, this is negative, this is positive. Oh yeah, so if you put these together, so if you have just here I, this I will be the same as what? Yeah, it'll equal the two of them. So even when this one adds to this one to go here, it's still all the same. There is another reason, Lee. Here, if this is negative and positive and this is negative and positive, what happens is this one and this one cancel, leaving you with just this and this, which is just 1 and not 2. So I know this is one capacitor and this is one capacitor, but if you think about the middles cancelling, it's like you're back to one capacitor. It's really hard to explain, and the first time I saw this in a physics book, I didn't understand it. The second time I saw it, I didn't understand it. I feel like now I kind of understand it, but it's still difficult. So I just remember as a fact, these must be equal in series. For the same reason the current must be equal, the I must be equal. Is that okay? Are you sure? Am I still your fan? No.
No. I'm your fan.
He's not my fan?
No.
Yeah.
No, he is.
Wow.
Yes,
You have
indeed.
2 fans.
2!
Yeah.
And yesterday I had 0. It's amazing. Alright. Here is a question.
Yeah.
Looks like a nice evening today. And those suckers in GNIB sweating with all the other students.
Finally, a weekend without feet.
Yeah, you're right. Still a long weekend to go. It's only Friday evening, don't rule it out. You still have Saturday and Sunday. That's it. Okay, you have this. Yeah. Continue now? Okay. So, I think it's just the one example to do, although it's a long one. I would like us to do this together by parts. So, you have 2 capacitors, a 100 milli and a 200 milli, and a battery of 10 volts. So maybe it's like a 5 and a 5 or something. So the first one is just draw this if they're in parallel. So that's what I just want you to do first, just to draw it and show me. Please include the numbers on your diagram. Do you draw it? You got it? Can I see? Yusuf? No, you're not. Oh, you are Yusuf, yeah. Where is it? Which one? That one. Yes. Interesting how you draw your battery on the top. I wonder if it's a cultural thing. Where did you draw your battery? On the bottom, yeah. Which is what I would have done. Fuan, can I see your diagram? Where's the battery?
Where's the battery?
The 10 volt battery, where is it?
Sorry.
Where's your battery? Not ours.
Yeah, okay, good. Lee, can I see what you drew? Omar?
Is there a difference in the batteries up or down?
No, there's not. It's just interesting because I would have always drawn the battery on the bottom. Is it cultural? Is it a cultural thing?
That's the way I learned.
Yeah, okay. Okay, let's draw this one. Okay, so you should have this. Oh, that's ugly. Sorry. 10 volt, 100 farad, 200 millifarad. That's the first part done. Okay. Part 2, calculate the total capacitance. Right, I'll give you 20 seconds to do that. Although that's probably 19 seconds more than you need.
Can I see the question?
Which picture?
Question.
Oh, okay.
What is happening? Sorry? What is happening?
What?
H-E-L-D.
Held. Hold.
Oh.
You know this word, hold? H-O-L-D? I know you do.
Yeah.
Oh.
Yeah, it takes together.
Yes.
Oh.
Yes. So what charge is held? Holds the charge, the coulombs. Yeah.
So?
What is the charge? That's the question.
The total.
Yes, the total charge. Yeah.
Why is not asked like that?
Because I'm trying to improve your English. Okie dokie. You got that? Okay. No, it doesn't, but somehow people are still writing. What's the total capacitance? 300. Yes, 300. What is the charge on each capacitor? Yes. When do you not calculate in physics though? Okay, have you worked out the charge on each? Yeah, you have, yeah. So what formula did you use, Yusuf?
Q equals CV.
Yeah, Q equals CV. So for this one, it would be 100 milli times 10. So that's 0.1 times 1. So 1, was it?
Or 1,000 milliliters.
Or 1,000 millicoulombs, otherwise known as 1 coulomb, correct? And Q2 is C2V2, which will equal 2 coulombs. Okay, part 4 now. What is the charge in total? Yeah, well, you can use the same formula. Q total equals C total
Sorry?
times V, yeah?
Why is it 1 and 2 column?
Column. 100 milli, that's the C, multiply 10 is equal to 1. Yeah? So this is What's the total capacitance? Total capacitance? 300. So it's 0.3 times 10, which is equal to 3 coulombs. Funny enough, 1 plus 2. Okay, what's next now? Right, so last part for this first half is what is the voltage on each capacitor. So what's the voltage here, and then what's the voltage on this one? Yeah, it has to be 10 because it's parallel. But to check, we can use the formula V equals Q over C. So let's check for the first one. Q1 is 1 and C1 is 0.100, so that equals 10, as you said. And what's V2? That's Q2 over C2, which is 2 over 0.2, which is also 10. Again, I'm doing this to show you that it's the same deal as last time. Yeah? Question here? Oh, to the question. How many lessons do we have left? In other words, how screwed are we? What time is what's the last teaching week?
The week before the 3rd of April.
The week before the 3rd of April. That's the last teaching week. That week. Because your exams are the 3rd of April. Ah.
Birthday.
How many hours do we have per week?
3 more weeks.
3 more weeks? 18 hours. 6 hours a week. 3 times 6. 18 hours. Oh, well, that's okay actually, because we're in the middle of this one. So we have 1, 2, 3. We need to do the remainder of this, which is 5 more lessons. And the next chapter, which is waves, which is only 5 lessons. So we have 10 lessons to go. That's okay. But it'd be nice to be finished sooner, so yeah. But I suppose it's most important to be finished. Okay. Did you have this down? Now, I want you this time to do everything again except put them in series, and I'll wait for you to do all the parts before I do all the parts. So I don't think I need to do it one by one. The only difference is it's in series. Okay. 3 minutes? Maybe 4 minutes. What do you think, Fanula?
10.
No way, man. No way. Not happening. Get started. You don't want to do it? You did them all. You are much smarter than these boys, huh? They're still doing it. Look how slow they are.
No. Instead of listening to you, I do.
Oh, I see. Like that. So these are good boys. They listen to me.
I'm a bad girl.
You're so bad. Bad Fanula. Did you get your fish?
Yeah.
Great. Did you have a picture?
No.
You don't have a picture of your pet fish?
I just have the first fish, I didn't have the second fish.
You just got one fish.
No, I mean the last fish, I have that picture, but the fish I got,
You don't have a picture.
yeah.
What happened to the second last fish?
Second?
Yeah, the second last.
What?
The one you have the picture of. What happened to it?
No, not that.
Oh no!
She bought. She upset. So I have to buy a male.
How do you know if a fish is upset?
She tried to pull out.
She tried to get out.
Yeah.
Really?
Yeah.
How does a fish try to get out? Really? No.
Yeah.
The fish tried to get out because it was bored, because it wants another fish. And this is why you bought another fish.
I have to buy the female and the male for that fish.
Really? I think this is your imagination. It's not true. Does anyone believe this story?
That's why I have to make the black thing, you know?
Oh.
I have to make the something up and that so the fish can't get out.
I use a cover.
A cover, a lid. So did you go into your room one morning and the fish is on the ground?
No, when I'm at home,
Yeah.
I saw the fish try to jump out.
That's amazing. I'm going to go home and tell my wife this and she won't believe me. Said, do you know fish tried to escape? This is a true story. I think we need a video of the fish trying to escape. What do you think?
Not anymore because now.
Yeah, but you should take the lid off and...
Why would she escape you?
Huh?
Why would she escape?
Oh, that's true.
She would kill herself.
But yeah, that's true.
Yeah,
Well,
because the man who fell the fish
yes.
for me, he said the fish can be stressed.
Now, this is an honest question. Was this person selling the fish? Was he an Irishman? Yeah, because sometimes Irish men like to make jokes. So I don't know if he was joking with you.
No. At first time I'm not believing him, but now I believe the fish stressed.
It's a stressed fish. It's a stressed fish. Yes. Yeah. Okay. Right. I knew this class was strange the moment I saw you. Okay. Let's put them in series now. So, what was the first thing I asked for when it's in series? Oh, to draw it. Well, there's not much difference in the diagram. Okay, what did I want first? The total capacitance. So we have to do 1 over C is 1 over 100 plus 1 over 200.
Wait, where the book?
Oh,
Actually,
I'm being lazy.
But
There.
no, 10.
Give me a moment. Okay. This is 3 over 200.
Yeah.
So C equals 66.7 millifarads.
Is there 100 milli? 1 over.
Yeah, 1 over 100 plus 1 over 200 is 3 over 200. But my answer is in milli because I know these are in milli. Do you get what I'm saying? What's next? What's the charge on each? Well, the good thing is the charge on the first one equals the charge on the second one equals the total charge. And what's the formula for total charge? C total, V total. What's C total? 0.0667 and V total 10. So the answer is 667 millicoulombs. Right, what's next? What's the charge held in total? Also this. What is the voltage on each capacitor? So V1 equals Q1 over C1, which equals 6.67 volts, and V2 equals Q2 over C2, which equals 3.33 volts. What's V1 plus V2 here? Should it be 10? Yeah. What's wrong, Fawn? Problem? What's the problem? Can I continue? Are you happy with that, Fawn? Yeah. Lee? Is this okay? Are you sure? Are you sleepy? What? Okay. Alright. Okay, continue, Fawn. What? I need to continue. You give me a question or not?
3.335.
Yeah, close enough.
But 35.
I know, because I did this in my head. No calculator. What? I'm continuing. Leave me alone. Right. This is your homework. I'll let you start it for 5 minutes, and then I'll do the next lesson, and we'll do the homework in the next class with the other lesson as well. So I'll give you 5 minutes. You probably, in fact, I think you could get them all done in 5 minutes. Yeah, actually, you should get this done in 5 minutes, because they're kind of easy peasy, right?
Do I have to draw?
I do not ask you to draw, so you do not need to draw. Actually, will it be less than 5 minutes? Which one are you on, Swan?
Oh.
Excellent. If you work hard, one day you can be just like her. Finished one? Which one are you on? Excellent. Done?
No homework.
Hmm?
No homework.
For this. I'm so mean, I know. Omar? Which one are you on? Yusuf? Lee? Okay. Fuang's going to give us the answers. Fuang, what's the answer?
Wait, the question is nothing from.
Huh?
How much?
We'll see what answers people get.
And inside the total. So it's just one question, right? How much?
Find the total charge.
Yeah.
Right, what's the answer for number 1, Fuang?
60.
What?
60.
60 what?
60. Microfarad. 60.
60. What did you get, Wang? Oh, no, you see, because yours is not the same, it means I have to write it down. What's the formula that you use?
1 over C.
1 over C.
Yeah.
Equals 1 over C now plus
1 over C.
Yeah. And what did you get?
400.
What?
4,000 maybe.
What?
No. What did you do wrong? You did something wrong. Oh.
Maybe because we changed it.
No.
60.
But it still should be the same number at the
1
front.
over 100 times 10 to the fourth minus 6.
Like this?
No.
Down the bottom?
Oh, yeah.
Fine, okay. Should be the same. Plus 1 over...
Plus 1 over 150 times 10 to the power minus 6.
Okay, so let's add these together, right?
Yeah. You get 1 over 4,000.
No.
Yes.
Oh, he never flipped it.
I did flip it. I got 1 over 4,000 and then flipped it.
Let's see if his story makes sense. Look here, you. 1 over, what's the first number?
100 times 10 to the fourth minus 6.
Like this.
Yes. Plus 1 over.
150. Something's wrong here.
Wow.
This. Flip it. She's right, and he's right. You have trouble using your calculator. Okay, continuing. Fong, what's the answer for number 2?
1,500 microseconds.
Yeah, that's one way to put it. 1,500 micro what? Coulombs, or another way. Number 2, she said 1,500 micro, which is unusual unit to use.
So it's 1 part time multiply 10 to the minus 3 coulomb.
And what's 10 to the minus 3?
Power.
What's 10 power minus 3? Milli.
What?
It doesn't matter. 1,500 micro coulombs. What did you get, Yusuf?
1/400. I can't misuse my calculator every
Well, you just have.
Is that radian or cell?
It doesn't come back.
Oh, there was
It should be in which
Huh?
yeah, which use mode what? Like mode 1?
Yeah, mode 1.
Mode 1, right?
Yeah.
Yeah, that's what I have.
No, don't make me do another one.
That's fine. Yeah.
What did you get for number 3?
1,000.
Good. So 1 kilovolt.
Yeah.
Yeah. And the last one, Wong, what did you get? Total charge?
7.2.
What? 1/2?
7.2 what?
Milli.
Millicoulombs. What did you get, Wong?
1.8 1,800 microcoulomb.
And what did you get?
7.2.
What did you get?
I don't know.
Okay, let's do it. A 100 is in parallel to 200. Farads, 200 microfarads, and then that is put to 300. Right. The first thing I'm going to do is add these together. So when you add them together, this becomes 300 and this becomes 300. So now I want to add them into 1. So 1/300 plus 1/300, 2/300, which is 1/150. So this is 150 microfarads. We know the total voltage and the total capacitance, so we can get the Q. Q equals CV, which equals, what did I say, 150 times to the minus 6 times 12. So that's 1,800 microcoulombs, or 1.8 millicoulombs. Now, I didn't need you to, but you could work out the charge on each of them. This 1.8 is the total charge. That means here there's 1.8 and here there's 1.8. Because remember we said charges are equal when they're in series. But when they're in parallel, what happens? They add. So this charge plus this charge should add to 1.8. So you could work them out. But I know what it's going to be. because this capacitance is twice as big as this capacitance and the voltages are the same, it means the charge will be twice as big here as it is here. So that means this will be a 1.2 millicoulombs and this will be a 0.6 millicoulombs. Together they make the 1.8, which must be the same here. You could work it out by calculating it from this formula. Q1 equals C1V1 and Q2 equals C2V2. Do we know C1 and C2? Yeah. And V1 equals V2, which we could work out because we could get the V here and then take it away from 12 to get it here. Not necessary, just worth talking about. Okay, we'll start the next lesson.